Good morning, all of you. So the next session will be talking on blockchain and IoT security paradox. We will focus on the blockchain security, and then we will say how IoT and blockchain integration can bring you some choices to make the applications more secure. So blockchain, as already we have learned, so maybe we will again listen to the terms we have gone through. We have digital ledger, which is duplicated and distributed across individual computers. Now here we are doing interaction between nodes using collaborative updations to this ledger. We have public keys, private keys, which are considered as two secure cryptographic keys, which allows interaction within the system. Now we have one user who initiates transactions using the keys, and the other use this key to accept this transaction. So once this is done, we have together the users who are going to submit the transaction to public peer-to-peer system. So we have fast checking nodes who will check the information in the transaction, fact checking nodes, like we have miners. So we are going to ensure that the information agree with all the prior information, and we ensure that everything is validated, and only if everything is found correct, your new block is added. Otherwise the transaction is denied on this blockchain. Now, the main tenets of security on blockchain, we have to understand what are the things why we have adopted this technology, being a decentralized technology, though. So it relies on ledger which going to keep all the transaction. Now, the great point of vulnerability on this blockchain will be this master ledger. So once if the master ledger is compromised, it means the system breakdown is going to happen, and then the attacker can alter all the records, or the attacker can also read all the transactions. But again, you have to think here, because ledger in blockchain is decentralized, which means that there is no control with single user or single system. So we cannot say that master ledger being a single control or a single entity is going to be compromised and everything on this blockchain will halt, and we will get into failures. So we have to have an incredible, sophisticated, coordinated attack on thousands of devices simultaneously, so that we can actually gain access to the main ledger. Another tenet of security is the chain itself. So after ledger, we have this chain which exists on blockchain, and it's a long chain of sequential blocks. Now the chain represents the piece of a puzzle which is being shared, and on solving the puzzles, the miners gets the blocks validated to be added to this chain, and making this chain to be a longest chain, so that any new miner whosoever comes to this chain is well aware that where I am going to mine my block, or where the next block is going to be added. Now, if we see structurally, these records are way back to the system's launch. Anyone who tries to alter any transaction here would first have to alter all the transactions. As we already learned that we have a complete hash of the program of this transaction on the block, and then this has been saved, and we have to alter, and we have to, if we want to alter, then we have to alter all the transactions, and we have to come to the initial transaction where where it has been originated, and we have to do it accurately as well. So it makes the hypothetical tampering process much more complicated. It means very infeasible, or this is not a very practical situation where we can have such kind of the attack or intruding into the blockchain. And also it increases the overall security of the system when you have to have changes in the complete chain where already a longest chain is working fine, and you have to change as an intruder or attacker onto that blockchain, you have to change some things or some transactions. So it will take a lot of input as an attacker or intruder. Now, some more features about blockchain. We learned that traditional systems are more than just two users where we agree upon a transaction, and then we have more this payment processing systems which are modern, and which links in chain of verification, like buyer seller according with the third parties. So in blockchain there are hundreds to thousands of things where it becomes very, very infeasible because we have different nodes, and these nodes have a complete copy of the ledger as well, and these can independently work to verify the transaction. So if the nodes don't agree, then the transaction is going to be cancelled, and this system keeps the ledger TD and makes it nearly impossible to commit any kind of fraudulent transaction. So this way we have to understand that how the blockchain security is inherent with this technology, and how we are going to see that what are the possible rooms of attack still in this technologies. The another tenet of security in blockchain is obviously the keys, because we are using the cryptographic keys. So the keys are like, if we are using elliptic cryptography or any form of cryptography, so it's going to like give you all kind of security in your data set or in your transaction. So every cryptographic sequence is a very long, complex, and it's virtually impossible to decipher as well until you have the authorization to view it or so. And this two key system, where we have public as well as the private key, makes the transactions even more secure without sacrificing the transparency, which makes a system unique. Now, the points of vulnerability in technologies, or specifically in blockchain technology, if we go through, could be the complexity of the technology. Then we have the size of network, which also impact speed and efficiency of networks as well. Again, there are some politics which lie behind the adoption of the technologies as well. Again, politics of execution could be one point of vulnerability, whether we want to execute some critical projects using the technologies or not. Then we have third party systems, how the keys will be stored, and if the keys have been stored, like we have a proper authorization role and access management has been maintained for the keys, and there are traditional scams as well. But beyond this, the points of vulnerability which may be common to most of the technologies we are learning nowadays, the big question is that the technology we are working on right now, the blockchain, whether it is really safe or not. Inherently, if we see, this blockchain technology is safe. As I said, we have a lot of things. We have distributed data. We have ledger in most of the cases, which is available around the computers, around several nodes in this blockchain. So blockchain simply removes the single point of failure first, and then we have cryptographic proofs as well, and the game theory consensus mechanisms. So consensus in itself is a complete complex process which involves a fault tolerant step by step agreement or consensus by some group of validators or consortium of validators to agree upon something, and then finally the decision has to be taken. So inherently we can see we have these cryptographic proofs and consensus mechanisms as well. But sometimes the fundamental safety features may not mean that the blockchain security issues, they are completely non-existent, or we do not have any security issue at all. So we have to understand this thing, and we have to know that there are still some attacks which are possible on this blockchain. So the famous attack on blockchain technology is the 51% attack. Now, this 51% attack, what basically the attack do, it use it reverse the transactions that have taken place in this blockchain already, and it also come as a famous problem known as double spend. So, for example, you spend 5 bitcoins to purchase a motorcycle, and now once you have this bike delivered, so logic says that bitcoins are to be transferred as the cost of this bike, and again, as soon as this is done, this may activate an attack. So when we have 51% attack, what will happen in this case? The attacker is going to reverse a transaction. It will result in all the coins, like whatever you have spent into the transactions, these coins will be able, these coins will be reversed, right? And when you fund this transaction and the coins have been reversed, so attacker is going to be the owner of your motorcycle as well as the bitcoins you have used to buy it. Now when this 51% attack happens, like the other name for this attack would be majority attack. So whenever any intruder or attacker or anybody who is trying to attack a chain, so he has the ability to control majority of your network hash rate. And once the network hash rate has come under the uh, influence of this attacker, being holding a computing 50%, more than 50% computing power. What we actually mean by this, when we have different nodes, so if the nodes who are participating in a transaction, so once the transaction power or the computing power or the hash rate control moves, suppose we have 10 and everybody has some power, so 50 total power, so call it be 100, so the 51 power, like 51% of that complete total power on that blockchain transaction validation has come to an attacker, so it's going to be attacked. So it means that attacker with 51% is going to take over the blockchain, and it could be it will come in the form of an attack. So this is very famous attack. Whenever any transaction is carried on blockchain, usually we try to put this transaction into a pool of unconfirmed transactions. So it could be Bitcoin or it could be any cryptocurrency. Whenever this is carried on any blockchain, what happens after we put them in pool of unconfirmed transactions, the miners in return are going to allow they'll allow to select some transactions from the pool to form a block of transaction. Now for any transaction to be added into a blockchain, again the miner has to find some correct answer to any puzzle. Now miners will find the solutions to complex mathematical puzzles by using their computational power which they have. Higher you have the computational power or the miner has, it means the likelihood or the probability of finding the correct answer, which could be allowed to add a block onto the blockchain, that probability becomes very high. And when once you have a correct answer to a puzzle which has to be broadcasted to other miners, so it can be accepted only if all the transactions in a block are valid according to the existing record on blockchain. So corrupt miners, when they come to these blockchain, they will not broadcast the solutions to the rest of the network. So what this practice does is, actually it always results in the formation of two versions of blockchain, where we will have an original blockchain which is followed by legitimate miners, and then we have a second blockchain which is entirely used by a corrupt miner who is not broadcasting results of the puzzle to the original network. So a corrupt miner will most of the time continue to work on his own version of the blockchain, which in any case is not going to be broadcasted to the rest of the network. So with the second blockchain, which is now isolated from the network, the corrupt miner can spend his or her bitcoins on the truthful version of that blockchain, and the one where all the miners are already following. Now 51% attack is a famous Bitcoin blockchain attack, although, but it is also very very rare, because an attacker would need the computing power or the hashing power superseding all the millions of miners all around this world. So if a miner wants to initiate such an attack, so he would need to spend a good amount of, or a very large amount of money to acquire the mining hardware capability to compete with the rest of the network, because he has to buy all the resources, he has to have all the computational hardware requirements which need to get into this 51% majority gain of the computational power or the hash computing power of the transactions going on this blockchain. So even if we can say that this is fact, that most powerful computers in this world, they cannot compete against a pool of millions of other computers, right? So it makes the hard very very impossible, or the attack to be impossible. It's very hard to perform such attacks. But again, we should not say that there is no such possibility, because the bug in this blockchain, because for blockchain also we write some code, etc. So if there is any bug in the code of this blockchain, it could open the door for the miners, for these miners to produce new blocks. at a very fast rate, and this could initiate this 51% attack. So once a miner is able to generate, create blocks due to some bug in the code of blockchain, so he is able to do this 51% attack as well. So this is a famous attack which we should not see as an avoidance to blockchain security aspects. Once we are able to do this, so we are going to have these two formations as I already have discussed. So this is one of the attack, 51% attack. Another issue which happens in blockchain technology is the DAO attack. It's again a famous attack which already has happened on this blockchain. So what actually a DAO attack, or what is the basic of this attack? Let's know this. So we have an Ethereum network, which is a network of computers which are all running the Ethereum blockchain. So blockchain allows people again to exchange the tokens of values, and this value is known as ether, as we have already worked upon this Ethereum blockchain. So this is the ether is the second most popular cryptocurrency after Bitcoin. So Ethereum also helps you to write and put on the network all kind of smart contracts, right? So smart contract, which is a code which can execute on every computer. So people execute these programs after sending the ether to them. So this is simple Ethereum. Now DAO is decentralized autonomous organization. So how it started with, its goal was to collect the rules and the decision making devices of an organization, so that we could eliminate the need for the document, as well as people who can govern, who can create a structure with decentralized control. So instead of doing the manual process of governing as well as the structure creation, etc., a decentralized autonomous organization has been set up, and mainly we have to collect the rules. So here we have group of people. So these group of people is going to write the smart contract, right? So these smart contracts will run within the organization. Now with DAO, there will be an initial funding. So how it works, as I said, we have a group of people who are going to write smart contracts. Now the initial funding period it is started, or it is initiated, where the people they are going to add funds. Now these funds are added to DAO. Now how the funds, after the funds are added, these people would get some tokens, right? So tokens are going to represent the ownership, which has been represent the ownership of any person who has purchased by adding the funds on DAO. Now this is known as crowd sale. So initially the coin offering technology has been named as ICO. After that it came as DAO. ICO was initial coin offering, where again the coins were offered to purchase tokens, and then it's going to represent the ownership. So the more stake you will put into this, so the more ownership you will own for that smart contract, or the rules or decisions are involved into the governing of other transactions as well. So people are going to now make, once your funding is over, now when this funding period is initiated, you will act as a user who is going to purchase tokens, and then you will represent your ownership there. So once this funding period is over, your DAO will start begin to operate. Now how this DAO is operate, it do the things, how it is executed. Now people can make proposals to this DAO. These proposals will tell how this money will be spent. So and the members who have bought in this, like, who can vote for the approval of these proposals. So whosoever has the stake, whosoever has the membership on this DAO is going to make this proposal, that how the money, how to spend the money, and also they will act as a member to approve for these proposals, so they can vote, and based upon the majority of the vote, again it would be decided that whether this proposal has to be taken up or no. So now we have the very first DAO which was designed was Bitcoin, which is governed by consensus again among the core team and the mining network as well. And other this DAOs have been launched on Ethereum platform after Bitcoin. So once your crowd sale is over, so you have to first address the vulnerabilities here, that what could be the possible room of vulnerability when you have to start funding the proposals. So when this concept started, in particular, if we see the history of this DAO attack, so there was Stephen, who is one of this DAO's creators. He announced that there is a recursive call bug, and this has found in the software, but no DAO has been compromised, or no DAO has been on risk. So because DAO contains all the stake, all the membership, ownerships of different users on this blockchain, so this has to come as a very, very safe or secure Ethereum network, where the people who are putting anything on stake to purchase the tokens, or so, they are they could feel reliable, in a sense that their tokens or their memberships or their stake or their control is not going to be compromised at any point of time. Now, everyone who will write a smart contract, they have to move some amount of cash, and this vulnerability was discovered in other DAO, because after DAO there is a creation of child DAO, right? So child DAO is going to be it introduced the, because how this child DAO came into existence, minority on this blockchain, which means that the people whose decision were not taken into consideration for the smart proposal, or for the final proposal to be validated for this blockchain. So in that case, there is a group formation, which is a minority group. So for protecting them, this child DAO was being designed from the DAO. So they were able, this minority group was able to retrieve their funds once the proposal gets approved despite their objection. So there is a group on this, in this DAO, where few people may they may object on the proposal to be approved. So it happens in every agreement or every consensus mechanism, where we may have some group of people or miners who are not going to give their approval for any kind of proposal or so. So here this child DAO was created, and this become the possible room of attack for the attackers. So it was implemented, and DAO was split into two chains. One was minority, who will submit a special form of proposal along with other token holders who voted for the second special proposals, and now they could take their ethers into a new DAO, which is called the child DAO, because once their approval is not being taken into consideration, so they may retrieve their funds back. So once they retrieve their funds back, now the minority group has an option, like they could have their ether which can transferred into the child DAO. Now child DAO will also have the same abilities as well as the same restrictions as we have with the decentralized authorization. So we have DAO, and then we have a creation of child DAO. DAO will be the master platform where everybody will enter as a member with some stake or some membership to vote for the smart proposals. And then minority is going to minority, those who have not been approved or whose decisions were not taken into consideration will form the child DAO chain in that case, with same structure, limitations, and also whatever vulnerability or security loophole is present in DAO, in the parent DAO, it means this could also come to the child DAO as well. Now, what is the attack here? The attack is that coder could found a loophole when your function split function is called when you have a child DAO to be splitted. So the code may have been written in a way to retrieve the ether first and then update the balance later. So this could be a software bug, or this could be a code bug where the attacker could get possibly into, and the attacker can also manage to recursively call this split function. So this split function, once it is recursively called, and we retrieve the funds multiple times before the code would check the balance. So this may so happen. This is the attack which has already happened on June 2016, where the attackers, they managed to retrieve approximately 3.6 million ether from the DAO fund, abusing this loophole, which is famously known as recursive call exploit. So this is one of the attack which has happened on blockchain itself, and popularly called as recursive call attack. Another security, so though for this attack, already, as people before proposing anything, they have to work upon the possible vulnerabilities. So the possible solutions have also come into the literature, like there are two possible solutions for this splitting of child DAO and getting attacked, are software fork and hardware fork. So these are two possible solutions with which the Ethereum platform is working with. So the software fork says that there will be no rollback, there will be no transaction, or the block which is going to be reversed. So no rollback is the one solution which could be there. And another solution is hardware fork, where the miners, like, they could be completely asked to just reverse the theft and return all the ethers to the DAO. Right, so the miners have to redeem, all the token holders will be redeemed automatically, and this DAO will be ended in that way. So one would be software, where the Ethereum platform itself can decide upon no rollback or any kind of transaction to be reversed, and hardware fork could explicitly ask the miners that please unwind this theft and return all the ethers to the DAO. So these are two possible solutions which exist in the literature. So we have 51% attack, and we have seen DAO attack, and already the attacks have happened. Like for 51% attack, there has been two, like, attackers by name of Krypton and Shift. They have two blockchains which is based on Ethereum, and it has suffered this 51% attack in August 2016 again. And in May 2018, Bitcoin Gold, which is at the time of this largest cryptocurrency, it suffered a 51% attack. Here the malicious users, they controlled a vast amount of Bitcoin Gold's hash power. So even the Bitcoin Gold repeatedly attempt to raise the exchange thresholds, but the attacker were able to double spend for many days. For several days it happens, and eventually the attackers were able to steal more than $18 million worth of Bitcoin Gold. So 51% attack, and this DAO attack has already happened, and we have to see for all kind of loopholes where the point of vulnerabilities could exist on this blockchain. And we have some related security issues as well. We have exchange hacks, like we have cryptocurrency exchange between two parties would become this a room for these attackers, honeypots for the attackers, because of their massive crypto holdings, right? And sometimes there are poor practices as well. Many exchange platforms are netly they are centralized, so they make the decentralized benefits of blockchains sometime obsolete. In February 2014, the exchange revealed that a hacker had stolen approximately $473 millions from this platform. And last year, the exchange lost over around $900 millions to hackers as well. When you are storing the cryptocurrency for your business, so you have to remember that not your keys, not your crypto, because whatever has been done is an inherent part of this blockchain technology. So if you do not have the control of keys, it means this is not your crypto. So the safest method to store your funds can be through either a hardware, or it could be through a paper wallet. So these methods, however, have minimal online touch points, which will keep your coins out of reach to malicious online hackers as well. If your business model involves the regular trading, you can use a decentralized exchange, which is DEX, which allows you to trade directly from your cryptocurrency wallet. Then you have more security issues like again, we have the related issues on all the technologies. We have social engineering attacks, where the most popular attack is phishing scam, and on blockchain it cost around $3 million, which was lost in 2018. There could be software flaws, where we have the most popular flaw in terms of software bug in wallets and D apps as well. So once you write the code for your wallets, once you write the code for your decentralized application, there could be any bug, and a small bug can lead to a big error and a big failure as well. So in 2018, $24 million in damages. Is going to continue work as we have a decentralized, and a lot of several nodes are participating here as miners, as validators, as users or so. But there are some possibilities where these attacks can cost high to this blockchain platform or technology as well. The reason being for software flaws, because we didn't do any rigorous testing, we have not audited well, or there is some code review missing from this code. So there are some software flaws. Along with this, we have malware attacks as well. Most popular attack on in malware category is the cryptojacking, where we have unauthorized and unnoticeable access to the resources. So this may range from malicious crypto mining tool to severe to server crash malwares. It also costs in multi-million dollars to the victims. So these are certain attacks, the security issues, other than the famous attacks, which are 51% attack and DAO attack. So other than that, we have these exchange issues, social engineering issues, software flaws, as well as malware. So if we see the IoT and if we see the security, just look into we'll not get into IoT details, but we'll look into the security aspects, because we did worked upon the integration of IoT and blockchain. So we can see the two basic formations where, or the possibilities where we can integrate these two technologies. So major attack on IoT was in 2016, where a hacker was able to found a loophole on a specific model of security cameras, and nearly 3 lakh internet of users video recorders started to attack multiple social network websites, and they brought down Twitter and other high profile platforms for almost 2 hours. So this has been a very famous attack in 2016, and this is one of the example why we said that IoT devices may have poor security and they may be breached at any point of time. So not only the video cameras, but anything with an internet connection, as we are working on Internet of Things, from refrigerator to smart locks, to thermostats, to light bulbs, vehicles, and even smart toys can also IoT security challenges and risks. So layer wise, if we see the security issues on the IoT platform, we have different layers. So at the perception layer, the attacks could be on the strength of signal sensor nodes in the IoT devices may be compromised, and inherent nature of network topology can sometimes be there. So perception layer is mainly linked with the strength of signal sensor nodes and the network topology. So here the confidentiality exploit can be in terms of replay attacks, can be in terms of timing attack, can be in terms of this node capture attack. These attacks could be active, or these could be passive. And the origination of these attacks could be through the internal network itself, or it may be due to some external sources. At network layer, we have this denial of service, and it's highly susceptible to man in the middle attack as well. Communication heterogeneity is one of the room, and then compatibility issues are there. So the confidentiality exploit here is in terms of traffic analysis, it's in terms of eavesdropping and passive monitoring as well. So few people who are not active there, they will passively monitor all the communication, and then this could lead to some confidential exploit as well at the network layer. In IoT at application layer, we have different applications which use different authentication schemes. We have different users who interact responsible, and they have some amount of data to reveal. And we have large overhead on applications as well. So here availability may compromise. So these are some basic layer wise like possibilities where we could have IoT security loopholes. So there are more issues which we can tell, that attacker was able to trigger a cooling and heating system at the same time, which is a very famous attack, which is known as Mirari botnet attacks in 2016. So it's highly vulnerable to malware attacks, and the challenge was for power grids, for manufacturing plants, for transportation. So attacker had this cooling and heating system triggered at the same time. So what it did, it created spikes on the power grid, which is a very big scale attack. Hackers can create a nationwide power outage, which already has happened. Another issue was a ransomware attack, where we have black hat hacker world. So your imagine your vehicle will not start unless you pay a ransom fee, or your house is locked down with the thermostat set to the maximum temperature. So these are some of the possible attacks with the use of IoT technology. And also there are data integrity risk in the risk of this IoT security in healthcare as well. So sometimes the IoT devices may send the collected data to cloud without any encryption. So what will happen as a result, the hacker is going to gain access here, and it is going to, he or she is going to control to a medical IoT device and alter the collected data as well. So we have a controlled medical IoT device which could send false signals now. It will make health practitioners to take actions that may damage health of their patients as well. So worsen the situation, there are risk of IoT security in healthcare devices like pacemakers, or the ones who are making the insulin shots as well. One of the case study you can get into detail for this IoT security attack is by St. Jude Medical's implantable cardiac gave access to hackers, which enabled them to alter the pacing or the shocks, and even worsen this thing, it has depleted the battery. So this is one of the IoT attack which has already been there. So you can go to this case study and just read the detail about this. Then we have crypto mining with IoT bots. This is another possible issue when we integrate this blockchain and this IoT platform. So attack involves the infected botnets which aimed at IoT devices with the goal not to create any damage but to mine the cryptocurrency itself. Now the open source cryptocurrency named by Monero is the first to be mined using infected IoT devices like video cameras. So although we have video camera which does not have powerful resource to mine cryptocurrency, but we have a lot of them which could do this. So IoT botnet miners, they pose a great threat to the crypto market as well, as they have the potential to flood and completely disrupt the market in a single attack. These are some of the countermeasures. We have authentication measures, which was proposed by Zaho in 2011 for mutual authentication scheme between platforms and terminal nodes based on hashing and feature extraction, irreversibility nature of both. So these are few of the measurements which could be taken or which could be adopted. Then we have ID authentication as well at the level of sensor nodes. So we can have dynamic variable cipher, which use the pre-shared key metrics using IoT. We have trust establishment, where the devices in IoT can physically move and trust can be established between the owners to have a smooth transition of the IoT devices with respect to access control as well as permissions. In 2013, WANG came with mutual trust for inter-system security as well, where the creation of key and token were there. Then we had federated architectures as well. Universal policies were designed with some standards and internal autonomy, and heterogeneity on software devices and protocols was being designed, proposed. Now we have to resolve IoT security issues with blockchain. So we can do this, and we can always integrate this IoT platform with the blockchain, uh, like the thing, and then we can have some security issues. Now the decentralization of any IoT network can solve a lot of security challenges like trustworthiness. We have decentralization, scalability, and autonomy, and it can also ensure the proper management of data at various levels. So in the context of IoT, blockchain could be applied to ensure the successful processing of multiple transactions, even the tracking, as well as the coordination of millions of smart devices here. Since blockchain technology is based on cryptography, its integration with IoT can provide again additional privacy and security. So the blockchain technology will get the transactions recorded, and this will mean that history of connected devices can also be recorded. So blockchain technology works with without central authority. So you will see that integration possibilities as well as the benefits of this is limitless. We can have any number we can like come through. And then the IoT with blockchain security can be achieved in two scenarios. Now, what are the scenarios? We have a company which integrates its connected device to get and transmit the data, and then it connects them to a blockchain network. So this is one of the possibility, one of the scenario, one of the case where we can secure IoT with blockchain. So first, the company is going to integrate all the connected devices to retrieve as well as to transmit the data, and then later on it is connected to a blockchain network. So this technology provides the ability for smart devices to exchange the messages, make the orders, and complete the transactions. Another case for this could be the Ethereum smart contracts are implemented by a company in order to automate the complete process. So before integrating the IoT devices, we could connect to the Ethereum smart contracts, which could be implemented, and the complete process may be automated. So this is going to provide the seamless and safe exchanges of messages between connected devices, as in blockchain based financial transactions. So these are two possibilities where we can secure the IoT with blockchain. So these are few of the security concepts or the attacks which are possible on blockchain. And when we integrate this blockchain with IoT, so we have to see in what form this integration will come to us. So this was all I want to discuss, because many key terms we have already been listening to the experts. So these are the repetitions where we can see we have 51% attack, DAO, child DAO attack, and